All right, guys, we're going to do a Unit 2 test review. Question 1, given graph of the quadratic below, which characteristic is false? So that's a very important false statement. All right. So the function is decreasing over the interval x is greater than 3. So remember, interval is an x-intercept. So we're reading it left to right on x-axis. So decreasing. So again, function starts here, which is at 3, and it's decreasing from 3, moving toward positive infinity. Because remember, that function, even though it looks like it's going down, it is going to be stretching to the right. Okay, so this is a correct statement. The function is negative over the interval, again, x-axis, okay, between negative infinity and 4 to infinity. So again, negative means negative numbers below 0, so below x-axis. So this piece right here and this piece right here represents our negative values, okay, of y. So it always comes again on the x-axis. It comes from a negative side to this point. This is where it stops, which is 1. And it goes from this point, which is 5, toward the right, which is positive infinity. This is where our negative values are going to be. So this statement right here is incorrect, okay? Negative infinity to 4 could not be it, because that would mean we'll be till here, okay? And this part is a positive. It's above 0, above x-axis, okay? So that could not be a correct statement, which is our answer. That's a false statement, okay? Just to make sure, the function has a range of negative infinity to 4. Okay, this is correct. This is negative infinity right here. We stop at 4 in a y value. And then the axis of symmetry is positive. Again, another correct statement because it crosses through positive 3. Okay, so B was our correct false statement. Okay. All right, next question. Given the graph of the quadratic below, which characteristics are true? Select all that apply, so there is more than one answer. So the first one, as x approaches negative infinity, so this statement says from a symmetry, from the middle of the graph, if we're going to go to the left, which is toward negative numbers, where is my function traveling? Is it going up or is it going down? It's going to go up. This is where the function is. It's right here. Okay, so this is also a correct statement. The range is negative 4 to positive infinity. So we start on the y value negative 4. And this is where our function starts and is traveling toward positive infinity. Okay, this is also a correct statement. So 1, 2 are correct. The function is increasing. That means it goes up from 3 to infinity. Again, this is, we're reading it left to right. Okay, and it's always going to be on x-axis. Okay, the values. So it says 3 to positive infinity. So let's see. Here it's where it starts and it goes up. This is correct. Okay, so not a correct statement. Domain is always going to be all real numbers, infinity, negative infinity, positive infinity, unless we talk about real life events. Okay, because again, these ends right here keep going and they're going to keep stretching to each side, you know, this way and grow to the positive values, and then they're going to go this way and this way and this way and grow to the negative values. So that's why we don't have the end on the x-axis where it's going to end. So this is also a true statement. 5, as x approaches positive infinity, so again, from a symmetry, from the middle of the graph, if I go toward positive number on my axis, okay, my function is traveling up. Here it says it's traveling down, so this is not a correct statement, okay? And again, if one end goes up, then the other one had to go up too because it's symmetric, okay? Now question 6, the function is positive over the interval, so again, x-axis, okay? From negative infinity to 0.1 and from 5 to positive infinity. So again, we're looking from left to right, and we're looking into an x-axis for positive numbers, so above 0. So these are positive above x-axis, above. These right here are going to be negative, okay? This is negative. We're not looking at these. We're only looking at the positive. So again, I'm coming from a negative infinity. I'm going to stop at this number right here. All of these values up here are positive, okay? So I'm going from negative infinity, I'm stopping at 1. Okay. And then I'm going starting back up, then they go negative right here, so I'm not going to touch them, okay? They go negative right here. And then from this point right here, which is 5, toward positive infinity, again, they're going to be positive, okay? So this is also correct answer. All right. All right. A ball is thrown upward from the top of a 40-foot high building at a speed of 80 feet per second. The ball height above ground can model by the equation -16t squared plus 80t plus 40. Use Desmos. So yes, I would use Desmos, and I already got it ready for you guys. Oopsie. All right. And so this is this equation right here. Okay. -16 plus 80x plus 40. So I'm going to make it smaller so we can see it. Okay. Right, so something like that. So again, this is a live event. So remember, you do not have negative values, and you're not going to have anything below ground. Okay, so this is represented as seconds, and this is represented as height as feet. Okay, so when the question is asking us, when does the ball reach the maximum height? When is a time-wise? Okay, so I'm going to go to the highest point of the ball. And my time is going to be 2.5 seconds, which is represented by x value, okay? So 2.5 seconds. What is the maximum height of the ball? Again, I'm going to go back here. Again, the highest the ball goes is going to be in meters, which is a y value, a feet, I'm sorry, which is a y value, which is 140 feet. Okay, so 140 feet. And then when does the ball hit the ground? And then again, going back to Desmos, it's going to be right here on the bottom. Again, the ball it went all the way up to 140 feet, then down, and here is the time when, which is the first, because it's at 0 feet at the point, the time is 5 seconds and 5.46. You can round it up if you would like to, okay? So 5.458 or 5.6 seconds. All right. All right. Next question, 4. Two characteristics of the quadratic function are given. The axis of symmetry is x equals -3, and the function has exactly 1, 0. So I can already eliminate answer A and B. Why? Because it has 2 zeros. Zeros means x-intercept. Okay. Okay. This is also 2. So again, I can eliminate that one. This one has 1, 0. That means it only touches in 1 point, which is either 3 or -3. Now, we do know the axis of symmetry means the middle of the graph, it goes through a -3 point. So I know it's going to be D, because this is where the axis of symmetry is going to go, through this -3. Okay, it's not going to be C. All right. All right. Now, using the graph below, answer the questions that follow. Path of the rocket is given by the question. We have a -16 t squared plus 120. I also want to mention that when you guys graphing, as you can notice, you got to find it. You got to change the t to an x. Desmos will not accept a t, so you got to change the values to the variables to an x. Okay. All right. So we are given the graph, so I can read it off the graph. So here it says, how long is the rocket in the air? Okay, so again, rocket starts at 0 seconds. It goes all the way up and back to 8 seconds. Okay, so 8 seconds, it's going to be in the air. All right, next question says, what is the maximum height of the rocket? So again, I'm going to look right here at the maximum point. All right, right here is the maximum point, and this value right here, it's 256 feet. It's a maximum height, okay? How high is the rocket after 7 seconds? So again, I'm going to look at 7 seconds right here. This is 7 seconds. I'm going to trace it to this point, and again, this is my feet. It's a y value, so 112 feet. The first letter, which is 7, it's seconds, okay? Now, is the rate of change of the height of the rocket greater from 0 to 1 or 3 to 4? So rate of change is our slope, okay? So we can do that and say slope. Everybody should be familiar with the slope formula. It says y2 minus y1 over x2 minus x1. So it's asking us the rate of change greater from this point to this point, so from 0 to 1, okay? So this piece, all right? Or is it from 3 to 4? Okay, so 3 to 4, this piece, okay? So what we're going to do is we're going to take these points, guys, and we're going to put them in a formula. So this is my x1, this is my y, x1, y1. This is my x2, y2. So we're going to take 112 minus 0 divided by 1 minus 0. Okay, so we're going to get 112. So that's for the point of 0. We got 112. That's our rate of change. Okay, rate of change. Now, from 3 to 4, again, I'm just going to pick x1, x2 here. Oops, again, sorry, y2 here. Sorry, x1, y1, x2, y2. Okay, so again, we're going to calculate it. I got 256 minus 240 divided by 4 minus 3. Okay, so that's going to be 16 over 1, which is just 16. Okay, so the rate of change between 3 and 4 is 16. Rate of change. Okay, so it's 16. So of course, 0 to 1 is going to be greater, right? The greater number, the greater rate of change. Okay, all right. Now, what is the domain of the path of the rocket? Again, this is a live event or live scenario, so you can't say the domain is all real numbers, so and negative infinity to positive infinity. So of course, we're starting from 0. Okay, and our rate of change, our domain, it's ending at 8. So it's from 0 to 8. Okay. Okay, because then again, this is where our graph is. Our graph is from 0 to 8 in that frame. Okay. Now, what is our range? So again, range represents y values, so that's up and down. So again, you're starting at 0 and you're ending at the highest number, which is 256. Okay. So it's 0 to 256 for y value. Okay, you're starting at 0 and 256 in between those 2 points. That's your frame of reference. Now, the interval, again, this is x-axis. That's what it means. Interval means x-axis. From 0 to 4, its function is either increasing or decreasing. So let's check that. From 0 to 4, so between these 2 points, is my function increasing or decreasing? It is going up. So it's an increase, okay? All right. Moving on. A swing team member performs a dive from a high springboard. So this is where it starts. This is a springboard. Okay. The graph below shows the path to her dive. The y-axis represents the height of the diver in feet. And then the x represents away from the board in feet. So both of them are in feet. There is no time or seconds. So what was the height of the springboard? It starts at 12 feet. Okay. How high was she at the peak of her jump? So right here at the top of the highest point, she was at 16 feet. How far away from the board was the diver when she hit the water? So from here, from 0 to here, okay, when she hit the water, she was 6 feet away. Okay. And then how far from the board was the diver when she was on the way down? You know, this one could be tricky, but again, this was her high peak right here. This is where she got on the highest peak. And then after that, she started going down. This is when the function is decreasing. So she was at 2 feet away from the board, right? From the middle right here. From the beginning, 2 feet away when she started going down. Okay? All right. Moving up. All right. So a graph represents quadratic equation. Analyze the graph, identify the request key characteristics. So y-intercept, it's at 6, so you can do y equals 6 or 0, 6 in the points. The vertex will be your minimum, okay? So that's at 3, negative 5. The interval, again, x-axis, okay, where the function is increasing. So again, increases, it's from here up. So we're going to find that mark here at 3 going toward positive infinity, okay? So it's at 3 going, oops, it starts at 3 going toward positive infinity. When the function is decreasing, so going down, it's coming down from here. So we don't know where it's coming down from. So it's a negative infinity from the left, okay? So negative infinity, and it stops at 3. It has to match for quadratic, okay? The same point. Now end behavior, again, you have a positive side and negative side. When x is approaching, so from a symmetry, from the middle, when x is going toward positive numbers, my function, their legs are coming up. That means that this must be up as well, because it's a symmetric function. But let's check. When function is going, oops, I did it wrong, guys. Sorry about that. I was looking at the positive, it was negative. When function travels toward negative infinity, okay, the function is traveling up. And the same thing should happen on the other side. When function is traveling from the middle toward positive infinity, my function also is traveling up, and that is correct. Now, interval where the function is positive. So again, positive numbers are those that are above x-axis, above 0. So this piece right here and this piece right here. So again, we're looking from negative to positive. We are coming from negative infinity all the way to this point, which is 1. So that would be negative. That would be positive numbers from negative infinity to 1. And then those numbers become negative. We don't want to worry about these. And then from 5 toward positive infinity, again, we have positive numbers above 0. Okay? All right, moving on. All right, so this is factor. So I'm going to work that out very quick. So you guys have factoring. I'm going to do A times C method. Okay? So again, A times C. So that's 35, it has to add up to 12. The two factors that I find are 5 and 7. They're going to multiply to give me 35, I add to give me 12. So I get x plus 5 and x plus 7, and I'm done. Okay, don't got to do nothing else. All right. Number 9, again, multiply. 1 times negative 40 is negative 40, has to add up to 3. Okay, so my two factors are going to be 5 and 8. And of course, to get a 3, 5 has to be negative. So negative 5 times 8 is negative 40, but if I add them, it's going to be positive 3. So that's x minus 5 and x plus 8. And since this is 1, I don't got to do anything else. All right. Number 10, again, negative 72 has to equal to negative 1. So I'm multiplying A times C and has to equal to negative 1 in there. There is a negative 1 in there. Okay. So again, the two factors are 8 and 9. And to get a negative 1, should be just negative 1. Negative 1, 9 has to be negative, right? So 8 minus 9 give me negative 1, so that's x plus 8 and x minus 9. And I'm done. Now, here I got a 5 as a leading coefficient. So I got to make sure in the end I'm going to divide. So let me multiply 5 times negative 16 is negative 80 and it has to equal 2. Two factors that I found was 8 and 10. Okay, 8 times 10 is negative 80 now. To get the positive 2, 8 has to be negative. So I'm going to have x minus 8 and x plus 10. Now I'm going to take this leading coefficient 5 and divide both sides by 5. Okay. Now 8 does not divide by 5. So negative 8, since it doesn't divide by 5, I'm going to move that 5 in the front. Okay, and make it a 5x minus 8. Since 10 does divide by 5, I'm just going to divide it to give me a positive 2. Okay. Now number 12, I got a 4 and I got a 9 and my b equals 0. So I can use a square root method and they are perfect squares. So it's a perfect way to get my answers. So 4x squared, square root of that is 2x. Remember, you're squaring the 4 and it's squaring the x squared. Okay. And square root of 9 is 3. So again, you're collecting 2 parentheses. 2x goes into both. And then of course you have, because we square rooted, you're going to have right here, guys, you're going to have plus or minus 3, okay, always when you're squaring, because you could have a possibility of having a negative 3 or the positive 3 as an answer. So negative 3 and positive 3, and that's it. That's your answer. And then lastly, again, I'm multiplying 4 times 9. That's going to give me 36. I need to find two factors and multiply to. 36 adds to 12, so I'm going to have 6 and 6. And of course, to give me negative 12, they both got to be negative. So two negatives multiplied give me positive 36, and two negatives that I add them gives me negative 12. So again, I have x minus 6 and x minus 6. Now, I do have a leading coefficient of 4, so I am going to divide both of those factors by 4. Now, can I shove that 4 in the front? No. And here is why. I cannot shove it up the front because I can simplify 4 and 6 more. So I'm going to divide 6 and 4 by 2. That gives me 3 and 2. Because you want to make sure it's in the most simplified form, okay? So now I have x minus 3 then over 2. That's my simplified version. And x minus 3 over 2. Now 3 does not divide by 2. So I am going to shove the 2 in the front now, okay? Which makes it 2x minus 3 times 2x minus 3. Now, these two are identical, so I can rewrite it as 2x minus 3 squared. Okay? Question 14, a quadratic has one intercept. Which of the following could be this quadratic factor form? So the correct answer is going to be C. Why? Because I have the same signs. I got two the same factors. Okay, so I can write them as x plus 1 squared, which now tells me that the function will only, it's going to be -1, it will only touch and bounce back up at one spot. Okay, so that shows you with two the same signs, two identical factors, that we only have 1, 0. Okay. All right, next question. For question 15, there's two ways of solving question 15. Okay, you can do it like we done before. You got 6x squared equals 42. We're going to move the 42 to the other side. So you get 6x squared minus 42 will equal 0. Now, the function is equal to 0. We are missing a b, so we do want to use this square root method for this quadratic equation because b is 0. Now, we cannot take a square root of 6, so first I'm going to see if I can simplify it by taking greater common factor out. So I'm going to divide both of these by 6 and take a 6 out, which leaves me with x squared minus 7 equals 0. Now, I'm going to square with this, what's left on the inside. Square root of 7 is kind of ugly, so you cannot take a square root of 7, but you can take a square root of x squared, which is x. And square root of 7 will stay as plus minus square root of 7. So now when I do put it into parentheses, x goes into both as double, and then plus root 7 minus root 7. Of course, 6 stays on the outside. Now you equal each of those factors to 0. So 6 will equal 0, x plus root 7 will equal 0, and x minus root 7 will equal 0. So of course, x does not equal 0, 6 does not equal 0, so that means that's not true. Here you're going to just move the square root of 7 to the other side, which will change the sign. Here the same thing, you will move negative square root of 7, change the sign, so the correct answer is B. So that's one way to solve it. There's another way to solve it when you're simply solving for x. Okay, so you get 6x squared equals 42. To solve for x, I got to separate the 6 and move it away because I don't want it there, right? So I'm going to divide because that's what multiplication is. So I'm doing the opposite operation, which is division. So now x squared is by itself, and this becomes a 7. Now to get rid of the square root, to get rid of the square, I can square root it. So these two will cancel each other out, which leaves me with plus or minus root 7, because of course whatever I do to the left, I dare do to the right. And square root of 7 cannot be simplified any further. Okay. All right. Now for quadratic, for question 16, which quadratic function has a root -5 and -1? So what I did, and of course you can solve each of those questions, but what I did was I plugged them into Desmos. So you can solve every single one of them and do a times c, so -5 and 4, find two factors, 1 and 5. One has to be negative x minus 1, x plus 5, and then equal them to 0. So this is going to be 1, and this is going to be -5, so that's not it. And you can go on and do that for each of those functions, but you can also do it by using Desmos, and I'll show you that in just a second. All right, guys, so yes, you can solve these equations by multiplying a times c, right, and figure out if those answers right here are correct, or you can use Desmos, okay? So I use Desmos. The correct answer for this question is D, first of all. So I went into Desmos, and what I did was I plugged these answers in, okay? So let me look very quick. For this one, the correct answer for 16 was D. So I went and plugged this answer in right here, okay? And again, you can plug in all of them and check if your roots, called also x-intercepts, are -5 and -1. So you can all plug in all these answers right here. Here you guys have x squared, okay? Plus, let's just say the middle one, -6. So I'm going to do C. -6x minus 5, okay? So again, this function, so answer C, had completely different roots. It was 6.742 or -0.742. So that one is not correct. So again, you can use Desmos. This was also not correct to get an answer D. Okay, so you plug them all in one by one and then checking which one has the roots they need. Got it? Okay. Now for question 17. Where do we go? 17. Okay. Again, I'm going to take this. Talks about Henry throws a tennis ball over his house. The ball is 6 feet above the ground when he lets it go. The quadratic function's model is this. Again, you can solve it if you would like, but I'm going to plug it into Desmos, okay? So I plug it into Desmos, and it's this equation right here, okay? It's -16x squared plus 46t plus 6, okay? And again, it is asking you, how long does it take for the ball to hit the ground? This is when it hits the ground, because remember, this is a live event, right? So you cannot have anything negative. This is your ground right here. This is your ground. So how many seconds does it take? 3, okay? X represents by 3. This is your height, okay, in feet. All right. So again, 3 would be your correct answer for this question right here. All right. Question 18, you have this equation, x squared minus 6x plus 4. Okay. Now you are asked which equation is the same. Again, you can solve one by one. You can take this equation right here and you can solve it. You can solve this equation first, which is going to be 4x squared. You have to find factors that multiply to 4 and give you -6. You can't, so you got to use a quadratic equation. Okay, so you're going to get -b, -6, okay, plus or minus. You're going to do -6 squared minus 4 times 1 times 4, because this is your A, this is your B, and this is your C, all divided by 2 times 1. Okay, so you guys are going to get +6 right here, because this is going to make it a positive. And then underneath the radical, you're going to get -6 raised squared minus 4 times 1, okay, times 4. So you're going to get 20 underneath the radical over 2. Now square root of 20 is 2 root 5. So you get x equals 6 plus or minus 2 root 5 over 2. Now, of course, I can simplify it by dividing each of these terms by 2. So this by 2 is 3, this is 1, this is 1. So I get 3 plus or minus root 5, okay? Now, I can take each of these, let's just say A, okay, and solve it, all right? So again, to get rid of the root, I have to get rid of the square, I have to square with both sides. So this is going to cancel out, leaves me with x minus 3 equals 2, okay, plus or minus. And now I am going to do and x minus 3 equals plus or minus 2. I'm going to add 3 to both sides. So x will equal 3 plus or minus 2, okay? So I get 3 plus 2 and 3 minus 2. So I get 5 and 1. Neither of them match this one, okay? So A, it's not it. I can do the same exact thing for B, all right? Where I'm going to do square root of x minus 3 squared equals 5. I can square root both sides. X minus 3 equals root 5, plus or minus. So again, x equals 3 plus or minus 5. This matches what I have here. So I know it's answer B, it's my answer. But again, if you don't want to do that, if you don't want to calculate all that, you can go to Desmos. You can plug in the main equation, okay? The main equation was -6 squared was this one right here. This was the main equation, okay? You can plug that one in, and then you can plug in your answers, okay? I only wrote down 2 of them here, all right? When you're looking, you can zoom it in, and you can see which equation matches the same points as the red one. So this equation right here, it's in red, okay? This equation is right here. These 2 points match with the black one. Black one is the one that matches the same. It's asking you which equation has the same solution, all right? So the same solution for the x squared minus 6x plus 4 would be x minus 3 squared equals 5. It has the same solution, means the same points where it crosses right here, okay? Does that make sense? All right. So, so this one would be answer B, okay? That's a correct answer, all right? All right, so the same thing goes for question 19. You are welcome to solve it because you guys should know how to do it algebraically. Okay, if you're solving it, again, you want to get rid of that square. To be able to do that, you got to square root it. Before you do that, you got to move away that 4. That 4 does not belong there. You cannot distribute it at all. That is a no-no. You have to divide because this is what it is, the multiplication. You got to get rid of it so that square factor can be by itself. Okay, now when it's by itself, you can square root it to get rid of that square. So we're going to square root it. That leaves us with just on the inside, which is x plus 2 equals plus or minus 2. Because remember, when you square rooting a number, it's 2 answers, positive and negative, right? Now we're going to subtract the 2. So we get x equals negative 2 plus or minus 2. That means I got 2 answers. One, it's negative 2 plus 2. And one, it's negative 2 minus 2. So this is 0 and negative 4. Okay? So again, the correct answer is A in this particular, okay, in this particular equation. Now, I can do the exact same thing and go and plug it into Desmos to check my answer, okay? I plugged it in right here. This is on the left side right here. I highlighted for you. This is your answers. Again, you're looking for where it crosses x-axis. It's your x values, which is negative 4 and 0. And there you go. You can check your answers, make sure it's correct. Is that okay? All right. So let's go back to now question 20. Again, you can solve it and check your answers in Desmos again to make sure that they are correct. We don't want you to rely on just Desmos. We want you to also know how to solve it. So if I want to solve that, I'm going to move the 36 to the other side. So I get x squared minus 12x equals, plus 36, okay? Now, I can find 2 factors that multiply to 36, but give me negative 12, which is 6 and 6. Agreed? Now, both of them got to be negative to make sure that they give me negative 12. I get x minus 6 and x minus 6. So again, both answers are simply x equals 6, okay? So B is my answer. I can also use Desmos, plug it in right here, and make sure I check my answer, okay? So this one was x squared. Sorry. All right, this one was x squared. Okay. I have minus 12x equals 36. All right, so again, here it is. Let me see. No, it won't work this way. Look, guys, it will not work. You have to move the 36. Let me make it smaller to see. Oh, no. Let me see. Yes, it won't work. It will not give you the correct answers. Did I put it correctly? Oh, negative 36. That's where the mistake is. Hold on. Okay, negative 36. Okay, now it gives you a correct answer. Okay, it's 6. All right, that's the only. Let me make it smaller. Yep, that's the only answer it gives you. It gives you 6. Okay. So I just typed it incorrectly. So you can again check your answers as you go. All right. Now I'm gonna solve these ones. Okay. So here it's asking you to solve and then check your answers in Desmos. Okay. All right. Question 21. Again, you are asked to solve. So it has to be equal to 0. It always has to be in a standard form. Ax squared bx plus c equals 0. So the first question, it's not. I'm going to move the 2 to the other side. Okay. I get 3x squared plus 5x minus 2 equals 0. Now, let me see if I can do a times c with 2 factors, okay? 3 times negative 2 is negative 6, has to equal to 5. Can I use 2 and 3? No, I cannot, because if I multiply them, if I add them, it gives me 5, but if I multiply them, it will not give me negative 6. So I have to use 1 and 6, and of course, 1 has to be negative. So x minus 1 and x plus 6. Now, I do have a leading coefficient here, which is 3. That means I got to divide both sides by 3. Okay? So x minus 1 over 3. Okay? And then x plus 2. All right? Now, 3 does not divide, so I'm going to move it up front. So that's 3x minus 1 equals 0, and x plus 2 equals 0. Okay? X equals negative 2. I'm going to move that 2 to the other side. Here I'm going to add 1 to both sides. Okay? So 3x will equal 1. I divide it by 3 because I'm doing two-step equation, equals 1/3. So these are your two answers. Okay? All right, the same thing for question 22. 8 is on the other side. I want to make sure it's equal to 0, so I'm going to subtract 8 from each side. So I get 3x squared minus 8x plus 2 equals 0. Now again, I am doing a times c to see if I can do two factors. So 6 has to equal to negative 8. I don't think I can find two factors that do that. So I'm going to do quadratic equation. So x equals my a, my b, and my c. So x equals, remember the formula is negative b plus or minus root b squared minus 4 times a times c divided, all of it, by 2 times a. Okay? So now again, I'm going to do negative b. My b is negative, so I'm doing double negatives. Okay? Very important. Plus or minus square root of, let me extend that, negative b squared, negative 8 squared, minus 4 times a is 3 times c, it's 2. Okay, divided by 2 times 3, which is a. Okay, so now again, negative and negative, it's going to make it a positive. So you got a plus or minus. Underneath the root, when I calculate negative 8 squared minus 4 times 3 times 2, I'm going to get a 40 over 6. Now, square root of 40, okay, is 2 roots 10. So this is, again, 8 plus or minus 2 roots 10 over 6. Now, I'm not done yet because I got an 8 and a 2 and a 6, and I can divide all of these items by the same number, which is 2. Okay, so that's 4, that's 1, that's 3. So my final answer is 4 plus or minus root 10 over 3. All right, now question 23. It is set up equal to 0, so we don't need to move anything. Again, I cannot multiply negative 6 and get factors to 8 and 4. I mean, to get two factors and multiply to negative 6 and add to 8. So I'm going to do quadratic equation. This is my a, this is my b, this is my c. So x equals negative b, which is 8, plus or minus square root of 8 squared, okay, minus 4 times 6 times negative 1. All divided by 2 times 6, which is 8. So I'm going to go negative 8 plus or minus underneath the radical. If I add everything, I do 8 squared, okay, minus 4 times 6 times negative 1. I'm calculating it right now myself. I get a square root of 88, okay, divided by 12. Now, that's still negative 8 plus or minus. Now, square root of 88, okay, is 2 root 22 divided by 12. Again, I'm not done because I can divide 8, 2, and 12 by 2. So this is negative 4. 2 divided by 2, it's 1. And 12 divided by 2, it's 6. My final answer is negative 4 plus or minus root 22 divided by 6. Okay? All right. Now, the last one, okay, it's 24. So again, I can try to do 2 times 21, which is going to be 42, okay? And let's see, I can try to do 2 times negative 21, so that's negative 42, and it has to add up to negative 1. So this might work because I can get factors like 7 and 6, right? And 7 has to be negative, correct? So x minus 7 and x plus 6 are going to be my two factors. Now, of course, I got to remember I got a 2 here, so I got to divide both sides by 2. Okay, so negative 7 over 2 does not divide, but 6 does. Okay. Now, I could move that 2 in the front, but since I'm equaling it to 0, I'm not going to. So I'm simply going to take these two factors and equal it to 0, okay? And then x plus 3 equals 0. So here x will equal positive 7 over 2, and here x will equal negative 3. Okay? So these are going to be your two answers. All right. So 25, it solved the following. So again, this, it's missing b. So I can use the square root method. Well, I cannot square root 3 or 27. So the first thing I'm going to do is think about it. What can I take out? What could be my greater common factor? So I can take out 3 in both to make it easier. So 3 comes out. I have left x squared minus 9 equals 0. Now, it's fair to say that I can do a square root method and get a perfect square. So 3 is still on the outside, and on the inside, square root of x squared, it's x, and square root of 9 is plus or minus 3. So again, into parentheses, I am going to put x into both, and then plus 3 and minus 3 into it, okay? Now, it does say solve. That means that I have to equal them to 0. So again, I have 3 equals 0. Each parentheses equals 0, okay? Now, 3 does not equal 0. That is not a true statement, so this goes away. And then here we're just moving the 3 to the other side. So x equals negative 3 and x equals 3. Okay? This is your answer. So we find our answer, it's minus plus 3. Now, there is another way to solve this, okay? Which is simply solving for x, okay? So there's two ways. I showed you that, guys, earlier. So I can take 3x squared minus 27 equals 0. I can move, I'm solving for x, okay? That's what I'm doing. So I'm going to move 27 to the other side to get rid of it. So I get left 3x squared equals 27. I'm going to divide both sides by 3 because I'm going to get rid of this 3 because I want the x to be by itself. So that goes away. It leaves me with x squared equals 9. Now to get rid of this square, I'm going to square with both sides. So this is going to, oopsie, this is going to cancel out. Sorry about that. All right, so this is going to cancel out the x, the square. So you get x equals plus or minus, and square root of 9 is 3. So there's another way to do it when you're just simply solving for x, okay? Means you're moving everything away from that x to have a final answer, okay? All right, only a few more questions left. So again, here says below are some quadratic equations and their solutions. Use quadratic formula to show the solutions are correct. So again, this is your A, this is your B, this is your C. We're going to use a quadratic equation formula. So negative b, which is negative 4, plus or minus square root b squared, which is 4 squared, minus 4 times 1 times negative 5 divided by 2 times 1. Okay? Now, this is still negative 4 plus or minus. And of course, underneath the radical, when we simplify this, we are going to get, let's see, so we got 4 squared, okay, minus 4 times 1 times negative 5. So here we get 36 over 2. So we get negative 4 plus or minus 6 over 2. And again, we got two answers, negative 4 plus 6 over 2 and negative 4 minus 6 over 2. So we're going to get 2 over 2, which is 1, and then negative 10 over 2, which is negative 5, which both of those answers checked out. Okay, so the first one, 26, is correct. Okay. Now I'm going to do 27 the same way. I'm going to plug it into the quadratic formula. Again, this is my A, this is my B, this is my C. So I get x equals negative 10 plus or minus square root 10 squared minus 4 times 1 times 18 divided by 2 times 1. Okay, so I get negative 10 plus or minus underneath the radical. I get 100 minus 4 times 18. Okay, so that's 28. All right, now square root of 28 is 2 root 7. All right, and that's divided by 2, so negative 10 plus or minus 2 root 7 divided by 2. Now I can simplify that and divide each of them by 2, which is negative 5, 1, and 1. So I get -5 plus or minus root 7, which is also the correct answer. So this checks out. All right, now, this next question, 28, I can graph it. And I did right here. All right, this is the equation right here. It's kind of tall, so you got to make it a little bit smaller to figure it out where the peak is. So this is your maximum right here on the top. Okay. Now the question is asking you for 28, how long did it take for Jason to reach his maximum height? Well, let me see. His maximum height, which is right here. How long it took him? 0.5 seconds. Okay, so that's your answer. For the second question, it says, what was the highest point that Jason reached? Again, this is your maximum right here. So the highest point in feet, because this is seconds, this is feet, was 484 feet. And then Jason hit the water after how many seconds? So it would be landing right here in the water, which is, again, 6 seconds when he hits the water. So these are your answers. First one was 0.5 seconds. Second one was 484 feet and 6 seconds. Okay. All right, question 29. Again, we can graph this function. All right, I don't think I have this one graphed yet. So let's graph it. This is -16. Okay, again, you cannot use t, so you got to substitute it with x squared. Okay, plus 128x. All right, so let's clean this up. This is your function. Make it bigger for you. All right. No, too big. All right. Now again, the question is asking, how long will it take for the rocket? This talks about if a toy rocket is launched vertically upward from the ground level with that velocity of 128 feet per second. And then it says the height, it's h, and the t, it's seconds given by this equation. So again, using Desmos, first question is, how long will it take for the rocket to return to the ground? Okay. So again, you're going to click right here. This is where it starts. Okay. This is your start point. This is your end point. Okay. So this would be 8 seconds, okay? Question B, after how many seconds will the rocket be 112 feet above the ground? So 112 feet, okay, let me see what is 112 feet. Okay, so almost right there, 1 second, okay? So again, for this one right here, 1 second, it's at 112 feet, okay? Now, how long will it take the rocket to reach a maximum height? So again, maximum height is right here. That's the maximum height, and this is your second. So 4 seconds it will take to reach 256 feet. And what is the maximum height of the rocket? 256 feet, okay? So again, here you guys will have 8 seconds. Here it will be 1 second. Here you go, have 4 seconds and 256 feet. Okay. And then the last question right here. Again, you can guys calculate it by using quadratic formula. So again, this is your A, this is your B, this is your C. All right. You guys are going to plug it in. So you got -b plus or minus square root. You got 5 squared minus 4 times -16 times 150. Divided by 2 times a, which is -16. I get -5 plus or minus. If I plug it all into the calculator for underneath, all right, we get a square root of 9,625 divided by -32, correct? Now we're going to take a square root of that answer, square root of 9,625, and let's see, square root of 9,625. All right, we get a decimal. So we could just divide this by, let me see. We could just put it in all in the calculator, and the final answer would give us like -5 plus 96, square root of 9,625 divided by -32. I'm going to get positive 322. Because the other answer, so the time is this one, and the other answer is -291. And obviously we do not use a negative time. So this is how many seconds it will take for the ball to hit the ground, okay? We can also go and use Desmos to check our answer. The answer is, I don't think I plugged it in. And then again, we can put it all in Desmos and check the same answers. It asks us, find out how long will it take for the ball to hit the ground. Again, this is right here, 3.22. So if we take this and put it into the calculator, -5 plus root 9625, all of it divided by -32 in a parentheses like this. This needs to be in a parentheses. We will get 3.22, okay? If we do -5 minus, we're going to get the negative answer, which is not correct. So that's it. I do want you guys to also review margin of error, how you add margin of error to each candidate or each percentage, and how you, and if they overlap or not. I also want you to review all the sampling methods and stratified, clustered. You have sample and random, you have self-selected, surveys, observational, and experimental studies. I need you to review all that because that is also important moving forward for the test.